So our next project will be about also European reindustrialization. So Maya Khalid from EPES will be presenting us lean design.
Link design stands for link knowledge in design, manufacturing, engineering for next generation production. So basically, this project aims to provide new ways of working based on first enhanced collaboration across roles and locations, second efficient knowledge management based on lean development techniques, and third better integration by addressing data interoperability and also semantic heterogeneity. So the expected impact of this project is the optimization of engineering and design processes through quality improvement, but also cost and time reduction. So the proposed solution consists of an integrated view on data, information and knowledge across the entire product lifecycle. This solution actually is based on lean engineering techniques and principles, which enable efficient internal but also external collaboration. The platform is cloud-based, following service-based model, and which enables higher acceptance and adoption, namely by or in the context of SMEs. So, in few words, the project or the overall mechanism of this project is based on the one hand data federation of federation of data, information and knowledge using semantic technologies and also linked data principles, and on the other hand, based on data analysis for based on semantic technologies, but also enabled through listening mechanism and artificial intelligence, which enable discovery of new knowledge and acquisition. So here we have, actually this can be of importance in the context of quality control of manufacturing process through machine-to-machine communications. So here we have a short use case story which involves several goals and requires several resources. So it's the story about an automotive project manager who needs to learn through the design of car part to fulfill the European requirements. So he needs, or he contacts a mechanical designer who can fulfill the design of this part only with the new production process. So he needs to assess or estimate the life cycle cost of a new production line. So we contact the system engineer who calculates the new production line life cycle costs based on the design inputs, and then he finds out that a scrap rate is a significant parameter. So he needs to consult the quality manager who will provide vital inputs on scrap rate and how to reduce it directly from the production line. So then the system engineer can update the lifecycle cost variables, and this new information shows that the new lines is viable. This information is shared with the designer who gives the go-ahead and finalizes his design. So this information goes back to the project manager and closes the loop, all in all using one single platform that gives an access to data and information and knowledge about design, manufacturing and production. So value proposition of linked design are first federated data, information, knowledge. Second, entry point to high quality of services and resources, and third, collaborative access. So the first value proposition, which is federated data, information, and knowledge, means having an integrated ecosystem that interlinks resources from all lifecycle stages, such as CAD models, PLM data, production data, and structured knowledge briefs. The second value proposition is is the having a single entry point that gives easy access to resources and available services. For instance, we can have a real-time data access from the production line and also related services for real-time analysis and decision-making. I don't know if you have time, we have a video we want to present, okay, of TAMOIN, where we have do you want to comment here?
Well, I'm also working in this project. We're doing inspections of pieces from Succes where they have some certain cracks you can see. So the idea is to have metrology equipment at the end of the line, at the hot line, and doing 100% of the inspection of the pieces coming out and providing information about the area where that cracks have appeared, and also other information such as dimension of the crack, timing of the crack, and the idea is to link that information with other information such as temperatures coming out of the sensors from the stamping line, where we can then forecast in the future when those cracks happen and what's the reason for that.
The last value proposition of EP design is collaborative access to share and retrieve information and knowledge through some features such as child decision-making tools and task assignments. And I think that's all. Yeah. Thank you.
So our next project will be presented by José Alberto from Tecnalia. Next project is EPES, and it's about wind farm maintenance engineering based in Spain.
Thank you very much. So, I'm going to present the EPES project, and in particular, one of the three business cases that are inside the project. So, EPES project the main goal is to generate an eco-process engineering system that allows industrial companies to create services that provide some kind of optimization to the product life cycle. So, for example, if you want to optimize the functioning of a product, you can use this kind of services in order to provide this kind of optimization. But I think the best approach is to show you how to provide this kind of functionality through one of the business cases. So this business cases is related to the wind farm engineering, windmill engineering, and the leader of this business case is TAMOIN. TAMOIN is an industrial company dedicated to the windmill engineering, and they install and maintain wind farms in Spain and also in other regions in Europe. So the goal of TAMOIN is to optimize the maintenance practices to increase the availability of the turbines. So they want to optimize the energy generation for their clients. So technically seen, what they want to do is to improve the data capture from their systems, and they want to manage this knowledge through the EPES services. Okay, so let's see. Okay, I'm going to present now the requirements that were derived from TAMOIN. So TAMOIN had three types of requirements. The first type of requirements are requirements on installations, and what they wanted to do here is to manage data coming from the wind turbines and the main components. And also they wanted to combine this data with operation parameters. These operation parameters are technical parameters about the wind speed, temperature of the components, and so on. Okay? So they wanted to manage, on the one hand, this kind of technical metrics, and they wanted to assign these metrics to the different components to have traceability of the different data in the different components. Okay. On the other hand, they wanted to manage data about the maintenance. So what they do, TAMOIN, they have different operation centers. You can see the operation center. This is the representation of one operation center. And in this case, we selected one operation center in Galicia, in the north of Spain. Okay. This operation center has 3 parks with several wind turbines, and they have limited resources. Okay, so they have different cars. Some of them are fixed in the parks, and the others are moving according to the maintenance tasks. Okay. So they wanted also to manage this kind of data regarding the logistics and the main business, which is the maintenance of the different turbines. So they wanted to codify the availability of material resources, the availability of the human resources, also the different maintenance tasks and the constraints. Okay, so the third requirement is the requirements on production organization. Okay, I'm sorry, these are the requirements on engineering services. So what they want to do is to combine requirement number 1 and requirement number 2 about data, and they want to exploit this data, okay, in order to do several things. So for example, they want to optimize the maintenance planning and scheduling. They want to order the different maintenance tasks in time to optimize the activity. Okay. They also want to exploit the data regarding the identification of urgent maintenance tasks due to predictive analysis and prognosis. This can be done with data mining facilities. On the other hand, they want to prepare statistics, also reports and dashboards that contain KPIs for decision-making support. Okay. So these 3 parts are regarding the requirements. So, starting from these requirements, EPES is providing one solution. Okay. So what EPES is providing is, in this case, is an algorithm with scheduling capabilities. Okay. So you can see that we have inputs, we have constraints to the algorithm, and we have some outputs. So the inputs are the maintenance data we want to report, the tasks and the resources. On the other hand, and this is one important part, we have the objectives and the constraints. So these are kind of goals of EPES service. These objectives, for example, are the maximization of the wind turbines availability or the minimization of maintenance costs. Okay. On the other hand, we have several constraints. So, one of the constraints are the resources availability. Not all the resources are available for performing different tasks. Also, we have the compatibility of the tasks, the priority of the tasks with more priority must be done before the others, and weather conditions. Okay. On the other hand, we have the objectives. These are the output of the algorithm. So the objective, the outputs are, for example, a Gantt chart with the different combination of tasks. And on the other hand, we have sustainability KPIs or metrics. Okay, so in order to introduce these objectives and constraints, we have created a kind of sustainability intelligence network. Okay. So here we have. The summary of this is that the goals of the EPES service comes from the environment and from the virtual factory. So we have sustainability intelligence networks that provide inputs to the algorithm. So this, we can see that the algorithm is modeled by sustainability intelligence coming from external networks. Also, we have a system here for capturing data from the life cycle. We have data of maintenance and operations, and with all those constraints and data, we can create and propose to TAMOIN KPIs for tracking the improvement through the algorithm. Okay, once we have the algorithm, this can be encapsulated as a kind of EPES service. This black box is a service that is a functionality that has been promoted from the desktop perspective to the distributed domain. Okay? And the last part of this service is the connection to the business process. So you can see here the representation of a business process, the business process of maintenance. So here you can see that the different actors are interconnected through different user interfaces, and the EPES service can be called through automated tasks here. So using this algorithm and using the data coming from the process, we can combine and create KPIs, and we can see if the KPIs are converting or not. This means that we can see if the KPIs produced by the algorithm are similar to the real KPIs from the process. And if we have deviations, we will have to modify the algorithm.